Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई के रखिथिबी तमे सर्च करि परिबो ओके थैंक यू
हेलो स्टूडेंट्स आज टॉपिक रे हमें कोलोइडल सिंथेसिस विषय रे पढ़िबा सो फर्स्ट ऑफ ऑल लेट अस नो व्हाट इज ए कोलोइड it is a system composed of nanoparticles which are dispersed in a solvent, right? And a colloidal solution is a homogeneous dispersion of the particles or droplets of one phase, that is solute, in a second one. Okay, so now colloidal growth of nanostructures, that is your nanoparticles, represent a chemical method of synthesization, and it is a wet chemical method or liquid phase chemical synthesis technique, and it is suitable for large scale production of the nanoparticles, and this method creates self assembled monolayers, that is single layer. Okay, and hence they belong to the bottom up approach for the synthesization of nanostructure materials or nanoparticles. Okay, now there exist different variations of this chemical route, and therefore separate description of various techniques which are required. So colloidal semiconductor nanocrystals are synthesized from the solutions in the same manner as through the traditional chemical processes. Now the main difference which lies between these two are in fact that the product neither precipitates as a bulk solid nor remains dissolved. Okay, and upon heating the solution at high temperature, the precursors decompose forming monomers. Okay, so thereby they will nucleate and generate the nanocrystals. Okay, now a monomer is what? It is a molecule that can be bonded to other identical molecules in order to form a polymer. Okay, remember, mono means one, poly means many. Okay, now in this process the temperature plays a very important role, okay, in determining the optimal conditions for the growth of the nanostructures, and temperature must be kept high enough in order to allow for the rearrangement and annealing of the atoms during the synthesization process, and it must be also low enough in order to promote the crystal growth. Okay, so we have to maintain the temperature value at a particular range. Okay, so that means the temperature should not be much high, and also at the same time should not be much low. Now the next important factor which is to be considered during the nanocrystal growth process is the concentration of the monomers. So when the monomer concentration is high, then the critical size, that is the size where the nanocrystals neither grow nor shrink, is relatively small, which results in the growth of all the particles, and in this case the smaller particles grow faster as compared to the larger ones. Why so? Because the larger crystals need more atoms to grow than the smaller ones. Okay, so this will result in focusing of the size distribution in order to give the nearly monodisperse particles, that is the particles which are uniform in size. Okay, now the size focusing is optimal for the monomer concentrations such that the average nanocrystal size which are present is always slightly larger than the actual crystal size. Okay, so with the passage of time the monomer concentration will decrease, and then the critical size will become larger than the average size which is present. Okay, so the distribution will then defocuses, right? Now let us see what are the various applications of this colloidal synthesis method. So number one, this method can produce various semiconducting nanostructures. Then the semiconductor quantum dots can be produced by this colloidal synthesis from binary compounds which are like lead sulfide, lead selenide, cadmium selenide, cadmium sulfide, then indium arsenide, then indium phosphide, and then we have the ternary compounds which are like the cadmium selenide sulfide or cadmium telluride sulfide. So these quantum dots have diameters in the range of 2 to 10 nanometer, and they contain as few as 100 to 1 lakh atoms. Okay, now let us see the advantages of the colloidal synthesis method. So number one, colloidal synthesis of nanostructures is suitable for their mass production. And then a green or environment friendly synthesis technique is the colloidal synthesis method, and it is least toxic to all the methods that we have read about the nano particle synthesization, okay, or the synthesization of nanostructured materials. Then it is a cheaper, means less costly process and effective method of synthesis. And then the narrow size of particles, which is ranging from 2 to 10 nanometer, can be synthesized by this colloidal synthesis method. Okay, but however it has a disadvantage because of the controlling time and precursor is critical in this process. Okay, now let us see the various colloidal synthesis techniques. Okay, so basically we will see the three types of colloidal synthesis techniques. So number one is the synthesis through the supersaturated solutions. So initially some of the quantum dots were created in the supersaturated solutions with glass matrix, and in this approach molten silicate glasses, that is SiO2, are doped with such a heavy amount in order to make them supersaturated with the metal salts of the desired semiconducting material. Now the melt is rapidly quenched, that is extinguished, so that it will result in precipitation of the desired semiconducting material into tiny sheet nuclei. And here quenching is any process that results in the decrease of the fluorescence intensity of a given substance, and a variety of processes are there which can result in the quenching, such as your excited state reaction, then energy transfer, then complex formation, etc. Okay, now the glass solution is then given a secondary heat treatment in order to have a temperature of about 400 to 1000 degree Celsius. Okay, so this much of heat is supplied to the glass solution, and by varying the temperature and duration of the secondary heat treatment, the average size of the nanocrystal can be varied accordingly. Okay, so that the particle size will show a strong dependence on the initial concentration. Now the next second technique is the synthesis through reverse micelles. Okay, so it is again two types. Number one is the introduction of micelle. So what is a micelle? Okay, a micelle is an aggregate of surfactant molecules which are dispersed in a liquid colloid. Okay, so what is a surfactant? Actually, a surfactant is that substance which reduces the surface area of a liquid whenever it is dissolved in the liquid, right? So you must have heard or acquainted with a washing powder that is called your surf. Okay, so this surf actually come from these surfactant molecules, right? So it is also written here, surfactant is a surface active substance which increases the reactivity of the precursors, right? And micelles may also be defined as the particles of the colloidal dimensions that exist in equilibrium with the molecules or ions in the solution from which it is immersed. Now these micelles can be classified into two types, as you can see in this figure. The first one on the left side is the normal phase micelle, which is the case of oil in water, and it is having the hydrophilic heads which are in contact with the surrounding solvent, that is in the exterior part, and the hydrophobic tails, which are in the interior part, that is in the micelle center, which is the hydrophobic oil phase. Right. Now the second one is the reverse micelle, which is the case of water in oil. So here we have the reverse arrangement. The head groups are towards the center and the tails are extending outwards. So at the center we have the aqueous phase. Okay. Now the question arises, what is the difference between hydrophilic and hydrophobic? See, hydrophilic means water seeking, or you can say water loving, whereas hydrophobic means water avoiding or water hating. These micelles are small and approximately spherical in structure, and they're composed of few tens to few thousand molecules that attract one another and thereby reduce the surface tension within the membrane of a cell. So the number of monomers which are forming a micelle is called as the aggregation number, which describes the size of the micelle. Okay, now the second one, that is the synthesis of nanoparticles. Here the reverse micelles can be used for the synthesis of quantum dots or quantum wires, and in this preparation the surfactants or capping agents such as BIS, that is 2-ethyl hexyl phosphate, which is also called AOT, are used to create the small reverse micelles, which are consisting of a hydrophilic, that is having strong affinity towards water, and it is a hydrophilic interior and a hydrophobic exterior. Right. Now the aqueous solutions of metal salts, which are then introduced into these compartmentalized water pools, and subsequent reactions are conducted in the aqueous phase, whether reduction of the metal precursor using sodium borohydride or reaction with another chalcogen source. Here chalcogen means these are the chemical elements which are present in the group 16 of the periodic table. So these elements are like that of your sulfur, then selenium, then tellurium. Besides these, we have also in the chalcogen family the oxygen and the polonium, which is radioactive. Okay, so these elements are used for creating metal or semiconducting nanoparticles. Right. Now the coating of the nanomaterials with the capping agents will prevent the agglomeration of the nanoparticles, and after the reaction the nanocrystallites are sometimes extracted by adding a surface passivating agent which drops them out of the solution. Right. The recovered nanomaterial, which is in the powder form, is then redissolved in the suitable solvent, and the average size of the nanocrystallites is then determined by the initial ratio of the water to the surfactant, and often it is called W or omega value. Now the third technique for the colloidal synthesis is through coordinating and non-coordinating solvents. So the nanocrystals and nanorods can also be synthesized using the coordinating as well as non-coordinating solvents. So some of the examples of the coordinating solvents are like dimethyl sulfoxide, that is DMSO, then dimethyl formamide, that is DMF, and nitromethane, that is CH3NO2. Okay. Similarly, some examples of non-coordinating solvents are like carbon tetrachloride, saturated hydrocarbons, then fluorocarbons, etc. Okay. So here you can see the figure of the colloidal synthesis arrangement. Okay, and in this method the metal organic precursors such as dimethyl cadmium and trioctyl phosphine selenite, which are injected into a hot trioctyl phosphine oxide, and it is maintained at a temperature of about 300 degree Celsius. Right. So that the precursors decompose to yield the desired elements of the final semiconductor. Okay, and the rapid injection is analogous to the rapid quenching in case of glasses and in discrete temporal nucleation of the seed particles. So here you can see in this figure we have the Planck line along with the nitrogen gas and vacuum. So what is a Planck line? It is an essential equipment which is used for manipulating air and moisture sensitive compounds. Okay, then we have a thermometer. Obviously it is used to measure the temperature. Then here is a shrink containing precursors. So what is shrink? It is the injection or withdrawal of liquid from something. Okay, then at the bottom we have the heating crucible. Crucible we also know it is a metal container or a ceramic in which the metals or other substances may be melted or subjected to high temperature. Okay, so the solution is then slowly heated and allowed to control the growth of the particles in the coordinating or non-coordinating solvent, okay, which is shown in this figure. And this is quite analogous to the secondary heat treatment which is given to glasses. But however, in this case, the temperature which I said is maintained at around 300 degree Celsius, and it is comparatively lower than what is required in case of secondary heat treatment, because for secondary heat treatment the temperature is maintained in a range of 400 to 1000 degree Celsius, right? And it is given to the super saturated solutions of the glasses. Okay, now moving further, here in this method we can also determine the average size of the nanoparticles by the temperature and the duration of the heating, and it can be monitored with the spectroscopic techniques. So this is what I have taken from one book about the colloidal synthesis. Now this one is taken from another book which has given about the colloidal synthesis in a brief and concise manner. So I advise you to read from this book also, and by combining from both the books you make your note accordingly. Okay.
Thank you.